Okay guys, today we're going to make a quick video about scatter plots. Okay, scatter plots use something called bivariate data. Bivariate data is simply you have two variables in your data. Okay, in this case what we're looking at here is going to be study time versus your grade. Now, this is the same as an XY table that we have been working with most of the year. In this case, I will make my study time my X and my grade my Y. Okay, it's similar to a function as well because you're assigning a specific thing for each variable. So I have my study time, which would be my X value, and my grade, which would be my Y value. So this is just an ordered pair of 1.5, 80, 3, 90, 1, 70. That's how it goes. So when I make my scatter plot, you can see here I've got my points. Now, the reason this is not a linear function, one, it fails the vertical line test right here, and two, it's not linear. Now, you can see that there's kind of a line going up through here, and we'll talk about lines of best fit next week. But if I group my data, I'm going to circle all of this data. You can see the trend is that it's going up. Okay, so each point on my scatter plot lines up with a coordinate on my XY table over here. So this one is at 1 and 70. In my table, I studied for 1 hour. I got a grade of a 70. You understand how that works? Now, the term outlier, that is simply a point that would lie outside this data. This data as it stands doesn't have an outlier. But what if we had a student that studied for 4 hours and made a 65? That would put them down here. This point would be an outlier because it lies so far outside the other data. Now, the next thing we're going to talk about in this video is correlations. I was going to draw the graphs, but I had this handy-dandy workbook that's going to help us out. You have 4 different types of correlations here. But really what you've got positive and negative correlations, and you've got strong and weak correlations. And then no correlation. So I guess there's one more in there. So let's look at no correlation. It's the easiest to spot. No correlation here, if you look, the points are just kind of random. I say no correlation looks like you shot the graph with a shotgun. It's just points all over the place. Down here, this is what would be called a weak. I want to stress the word weak here. It could be weak positive or weak negative. The positive or negative is simply based on the slope. So here you notice they're kind of going up in a positive direction. That's a positive slope. But we say it's weak because if we circle all those points, it's a big oval. It's not quite a circle, but it's kind of an oval going up. Okay. Now, the third one here, this is a strong positive correlation. Because if you look, they almost form a straight line. You could draw a line between most of those points, but not all of the points. It's positive because the slope's in a positive direction, and it's strong because of how close it is to forming a line. The last one down here would be a strong negative correlation because it has a negative slope to the line. As the X increases, the Y decreases. And it's strong because of how closely they form a line. The closer they are to forming a line, the stronger the correlation. So if we look back at our first example, if we take the outlier off, this is going to be considered a strong positive correlation. I hope this helps. The next video I'm going to make will be on lines of best fit.